Today we are going to see about capillary electrophoresis. First, electrophoresis. Electrophoresis is a technique used to separate macromolecules in a fluid or gel based on their charge, binding affinity and size under an electric field. In the year 1807, Ferdinand Frederick Rieses was the first person to observe electrophoresis. Electrophoresis has a wide application in separating and analyzing biomolecules such as protein, plasmid, RNA, DNA, and nucleic acids. Next, capillary electrophoresis. Capillary electrophoresis is a technique used to separate molecules based on their size and electrical charge. In this technique, a sample mixture is placed in a small tube called a capillary. A voltage is then applied to the capillary, which causes the molecule to move through the tube. The result is the separation of molecules based on their size and charge. Next, principle of capillary electrophoresis. The velocity of an analyte migrating within a capillary under the influence of an electric field of intensity E is determined by the analyte electrophoretic mobility and buffer's electroosmotic mobility. The electrophoretic mobility of solute is dependent on the solute properties such as its electric charge, molecule size, and shape, and the buffer properties such as electrolytes ionic strength, pH, viscosity, and additives. The solute electrophoretic velocity is given by the following equation. Electrophoretic velocity equal to mu EPE equal to Q by 6 pi nr V by L, where N is the viscosity of electrolyte solution, V is the applied voltage, L is the length of capillary, R is the stroke radius of solute, mu EPE is its electrophoretic mobility, Q is its effective charge. Next, instrument required for capillary electrophoresis. High voltage power supply, buffer reservoir, electrodes, capillary, optical viewing window, injection system, detector, thermostatic system, recorder, suitable indicator or computer. Next, type of capillary electrophoresis method. First type is capillary zone electrophoresis. It is a method of electrophoresis that requires a capillary filled only with a buffer. The analytes are separated into bands whose velocity depends on their electrophoretic mobility and electroosmotic flow. This type of electrophoresis is efficient for analyzing substance with molecular weight ranging from small to large, less than 2000 to 1 lakh molecular weight. Next type is capillary gel electrophoresis. In capillary gel electrophoresis, a gel acts as a molecular sieve, separating molecules according to their size. Smaller molecules move through the gel network faster than larger molecules, allowing for the separation of proteins, DNA fragments, and other biological molecules. Type is micellar electrokinetic capillary chromatography. It is a hybrid of electrophoresis and chromatography, with separation occurring in an electrolytic solution consisting of surfactant above its critical micellar concentration. Next type is capillary electrochromatography. It combines the principle of capillary electrophoresis and high-performance liquid chromatography to achieve efficient separation. It is mainly used in the pharmaceutical industry to identify acidic and basic drugs and in the industrial sector for analyzing polymers. Application of capillary electrophoresis. In DNA and RNA analysis, capillary electrophoresis can be used to separate and analyze DNA and RNA fragments and to identify mutations and genetic variation. In protein analysis, capillary electrophoresis is used to analyze proteins, including determining their size and charge. In pharmaceutical analysis, capillary electrophoresis can be used to analyze drugs and to monitor their purity and quality. In environmental analysis, capillary electrophoresis can be used to analyze environmental contaminants, including toxic heavy metal and organic pollutants. Forensics, Capillary electrophoresis is used in forensic science to analyze and identify various substances such as illegal drugs and poisons. In food technology, capillary electrophoresis is used to identify flavonoids, vitamins, carbohydrate, proteins, pigments, and color in the variety of foods, including beverages and fermented food. Capillary electrophoresis may also detect DNA and RNA from bacteria and viruses, which is indicative of contamination. In disease diagnosis, capillary electrophoresis or lipid profile analysis utilizing CITP is essential for detecting charcoal level in clinical laboratories during disease diagnosis. In a similar fashion, capillary electrophoresis is used to analyze the vitamins and minerals in human serum. Advantage of capillary electrophoresis: high resolution, high sensitivity, high throughput, cost effective, versatility, non destructive, minimal sample preparation, less time consuming, has the possibility of automation. Next, disadvantage of capillary electrophoresis: changing capillaries is challenging, less robust, complex instrumentation, limited separation range, low sample capacity, interference, time consuming. Thank you.